Okay, so in this video I'll be showing you how to take the volume of a 2 by 2 by 2 square-based pyramid, doing integration by slices. So first step, always draw a diagram. Helps so much. Usually, just by drawing a diagram you can visualize it so much better, or well, at least I can. So this, each side is equal. So in this case it's 2, 2, and 2. We also have the drawn our axes. We have Z coming out the top and the bottom. We have the X going in horizontally like this. Pretend those intersect. And then we have Y kind of laying down the bottom of the pyramid like this. So how to calculate the volume? Well, since we're doing this by slices, we should slice from the bottom of the pyramid up. I think that'd make it much easier. I'm sure there are other ways to do it, but I would be willing to bet they're more painful. So to get the volume of this by slicing, we're taking tons of little rectangular prisms. We're just getting tons of little rectangles with a multiplied by a height. So for that, we just have I'm just gonna draw this in. We just are slicing this into tons of these. Difference is the width is delta Z, because it's in the Z direction. We're integrating in the Z direction, which is this way. And since these two are equal, normally it'd be length multiplied by width. And it still kind of is, they're just equal, so I'm just going to make them both equal to length. So the volume of this slice, so delta V, is equal to length multiplied by delta Z. That's cool. We can simplify that to delta V is equal to length squared delta Z. But then there's the issue of getting length. We have to get length in terms of Z. Well, that's not that hard. Again, we draw another diagram. With this, let's just graph the Z and X direction of this. So, as you can see, this is just a sideways cutout, I guess, of the pyramid. So we have from the distance from across the bottom is 2. Distance from the bottom to the top again is 2. And so this is the Z direction, this is X. What we're going to do is we're going to take half of this. We're going to ignore this half. It doesn't matter. We're just going to say that the length is equal to 2 of X, because X, we're just saying, is this half, right? Not this half. So to find 2x in terms of Z, if we have x, we can use the law of similar triangles. So if we have Z over x, right? That's the Z over the x is equal to, what's the Z in direction? There is 2 units in the Z direction. There is 1 unit in the x direction, because we're only taking half of the base length. So if we're looking for x, or if we're looking for length in terms of Z, what we can do is we can flip this. So we get x is equal to Z. I mean, we don't have to, it just makes it easier, in my opinion, easier to illustrate. It's equal to 1/2 multiplied by Z. Then we get Z over 2 is equal to x. So now that we have that, I'm just going to move this up here so you can see it better. We have L is equal to 2x, but we can plug in a z over 2 for x, which gives us with 2z over 2, 2's cancel, and L is equal to z. Wow, that was pretty easy. So with this, we can just plug that in with z squared delta z. Then we get the volume, and then we integrate. And since we're only going this way, well, yeah, since we're slicing up in this direction, we're going from 0 to 2, right? So we're taking integral from 0 to 2 of z squared dz. So the integral of that is just, that's a pretty simple integral actually. We can just do z cubed divided by 3 evaluated from 0 to 2, which gives us v is equal to 2 cubed over 3 minus 0 cubed over 3, which we can just, that's just equal to 0. Then 2 cubed is 8 divided by 3. So the volume is equal to 8 divided by 3 units cubed. And there we go, we've integrated the volume by slicing upwards. Hope you enjoyed this video. Leave comments in the comments section. Thank you.